Hello everyone, welcome back to alkaline hydroxide 784 and I hope it's quiet enough in here. But anyway, let's start. This is the mathematics series. I think my voice is echoing a bit, but never mind. And in this episode, we will be doing functions. Yes, functions. And we are getting into, I guess, business today. So instead of going into nitty-bitty details which you would have already learned in school, I will tell you how to tackle questions maybe or things that you definitely should know in general, and also some advice along the way. So the first thing that we will so actually how I'm gonna do is I just have a list of stuff. I'll just talk about each of those things. Of course, functions, you need to first ensure that it's actually a function. And sometimes questions, most of the time they don't really ask this, but if, before you start, unless it already says that fx is equal to this, you may not know whether it's a function or not, whether it can be a function. And for that, you would need to do the vertical line test, which means, you stick lines that are like parallel to the y-axis. If one good example of something that is not a function would be something like x equals to y squared. That is not a function unless you restrict it in a way, like y equals to square root of x, like the positive square root. If you only have that, then it's a function, but if you have both positive and negative square root, then it doesn't work. So that's for the function. You need to make sure it passes the vertical line test, because otherwise you wouldn't have a specific like for a certain x you wouldn't have a certain y. Okay, so the next thing that after you find out that it's a function, you may want to do certain things like making composite functions or doing things like that, like f(g(x), for example. And before you do a composite function, you need to see how the range of the inner function corresponds to the domain of the outer function. Like for example, if you have f(g(x), you would need to find out what's the range of gx and see how it fits into f's domain. So do take note of that when you're doing a question. And it's pretty easy to find the domain and range. For the domain, it's just which x is possible. Like if x is in a denominator, then obviously x equals to 0, not possible. Or if it's like x minus 1 and x equals to 1, is not possible, that kind of thing. And for the range, you just need to see how the function is, because there are some functions that go up to infinity and there are some functions that have a maximum or a minimum. So you can use those to figure out the range. Okay, so after you figure out the domain and the range, then you would, for example, if you have gx equals to x squared and then fx is 1 over x or something, then you're trying to find fgx and you need to know what's the domain for fgx. So gx can work for all x real, I guess, and fx would work only it can work for everything except for x equals to 0. So in this case, when you input g into f, basically, you would need to ensure that the corresponding domain doesn't include 0. At least you must write it down. fgx would be 1 over x squared, where x cannot be 0. That's basically how you would write it. So yeah, let's just make sure to write down the range if you are doing fgx, or even for your inverse functions, you would need to write it down. Okay, so the next thing is, of course I just mentioned it, the function with the inverse. So in order to have an inverse, like sometimes they'll ask you find the inverse of this, but they don't give you a specific range. Like for example, they say find the inverse of fx equals to x squared. So I think in this case, usually the teachers will tell you to say that fx equals to x squared without any specified interval. doesn't have an inverse because it doesn't pass the horizontal line test. And in this, maybe I'll cover how to do the horizontal line test properly. And to do that properly, you need to, if you are trying to prove that it is an inverse, it has an inverse, then you need to draw that line, the y equals to k, where k can be anywhere in the range of the function, and you need to say that it only intersects the graph at one and only one point, and therefore it has an inverse. But if you want to prove that it doesn't have an inverse, it's as easy as just giving a contradiction. Like for example, if you have x squared, you can say f1 is equal to f negative 1, which is equal to 1. So yeah, that's as simple as that. But if it does have an inverse, you need to find the inverse. So how do you do that? Well, I guess you already know. You just need to make y equals to fx and then make x the subject, and from there you will get your f inverse if you convert all the y's into x's. And if you do not know why this works, is because you know that the line of reflection for the function and the inverse is along the line of x equals to y, right? So in the sense that I don't really know how to explain this, but when you flip it along that line of reflection, the x becomes the y and the y becomes the x, that kind of a thing. That's how it works, and that's why this method works in a way. That's like the most vague way of explaining it, but you get the point. But anyway, that's besides the point. As long as you can figure out how to find an inverse function, it works. Great. Actually, an easier way to see it is like, for example, if you have you have something like e to the power of x and ln x, and you know that there's this thing where if you have e to the power of x is y, then ln y is equal to x. So those are two inverse functions in a way, and in that case, even without making anything the subject, you know that those two are inverse functions, and they're reflected along the xy line, x equals to y line. And in that case, every time you find an inverse function using this method, you're doing effectively the same kind of thing with each and every function, I guess. So anyway, that's besides the point. So after you find an inverse function, once again, you need to take note of the domain, especially, and if you want to take note of the range, actually that's pretty easy. The range of your inverse function will be the domain of your function, and the range of the function will be the domain of the inverse function. So you only need to find for one of them, and then you get the other one just by swapping it. And when you draw the two functions together, the best thing you can do is to make sure your x and y axis have a somewhat consistent scale, like the same scale. For example, if each one is like 1 cm-ish, make sure it's the same size for both the x-axis and the y-axis. And then when you actually draw it, even without having to plot the points, it's a lot easier to follow and draw the inverse function. And it also looks nicer, so might as well do that. It saves you time and having to actually calculate which point corresponds to which. So yeah, actually I don't have anything else to say, do I? Okay, actually the last thing on my list is potential area of carelessness. So how can you make careless mistakes in this particular topic? I do not know. There's so many different ways that one can make a careless mistake. So maybe I'll think of how I have made careless mistakes before, because careless mistakes can be your bane if you're good at everything else, but you just make a lot of careless mistakes. Okay, maybe the first one would be like if you find your domain or your range incorrectly. Like if you didn't take note of the maximum or the minimum, then your range may end up incorrect. Or if you didn't take note of the denominator, you may end up missing it out, or you may or instead of missing it out, you may just forget to write it down, which is more realistic. You just forget to write down your domain or range. Even if you know what it is, you didn't write it down, and for that you lose marks. So please do remember to write down your domain, especially your domain. Yeah. And then the other careless mistake would be that well, maybe when you're drawing your two functions, you may not draw them super smoothly, and or you may draw them you may draw one just a little bit wonkier than the other, and it may not look super accurate afterwards. And that's why I say you should use the same scale on both axes. If you use different scales, you're already giving yourself trouble. It just makes things harder. Apart from that, of course, if you got a function which doesn't have an equation and you're just supposed to draw the inverse, do take note of the intersections like y-intercepts, x-intercepts, because that will help you give a general idea of how the function moves through the graph, the inverse function. And even if you're not very confident of whether you can draw it properly, you would at least get your intercepts correct, right? Yeah. Yeah, so apart from that, the other way you may make careless mistakes is in writing down the functions itself, and especially when you're doing composite function or you're doing your algebra for your inverse function. Basically, yeah, sometimes you miss out something, like you miss out the power, like the square power or cube power or something, some kind of thing, or you accidentally put a minus where there's supposed to be a plus, or vice versa. Yeah, those are the kind of careless mistakes that can happen, and in order to avoid that, yeah, one of the ways to do it is to check, but most of the times you either won't feel like checking or you may not have time to check. So in that case, the best thing you can do is to be extra alert when you're manipulating the equation and don't hurry through it. It's better to, if you have problem with this topic especially, or if you have problem with this kind of careless mistake, then do take a little bit extra time to write down everything and keep checking in your head whether you're writing it down correctly. Of course, don't overthink it, otherwise, it'll become a mess. But yeah, just and I think generally right after you finish it, you will know whether you made a careless mistake. Sometimes, if it's a really, even a small thing can make a big difference. So you should have the intuition to notice that you actually made a mistake and your thing looks very different from what you have originally anticipated. You know what I mean? Yeah. And maybe one way of doing things is like if you find a function, if you have the equation literally written there, you can put it in your GC, and when you write your inverse function, you can put that in the GC and see whether it actually looks like the inverse function or not. If it doesn't, then for sure you have made a careless mistake. Yeah, so I think that's about it. Oh yeah, there's another thing that you may have to tackle, which is piecewise function. There might be a piecewise function in your question where you might do an inverse or a composite function. It could be possible. The thing with piecewise function is to just go through it piecewise and do it. Like don't get confused by the two different pieces of the function. Just tackle each of the parts separately, and then after that combine them when you're presenting the final answer. So yeah, I think that's about it. The next episode will be on graphs, and actually it's like graphs and transformations. So I will put one part about graphs along with maximum, minimum, that kind of thing, turning point kind of thing, and then the other part will be about transformations. So I hope you found this useful. If you have any questions, please do ask, because as someone who doesn't usually have problems with math, I may not know what kind of problems people have. So maybe there are some things that people actually have problems with in functions. I mean, it's more likely that I'm more likely to know what kind of problems exist when you're doing vectors compared to functions. So yeah, but if there are any burning questions, do ask them in the comments below or in Reddit. Yeah, so that's about it. If you found this useful, press the like button and subscribe, and that's about it. Thank you and bye.